Welcome to this Maths-Made-Easy video on the exponential function. To start with, let's just discuss the exponential function. Now, the exponential function is simply defined as e to the x. So the exponential function, we write it in full here, is e to the x. Okay. Now, e is simply just a number, and the number here for e, if we write it next to our title here, this is 2.71828, and this carries on. And it carries on forever because this is an irrational number, just like pi. Okay, so e is irrational. Now, e to the x has some special properties that we need to be aware of. The most notable being the gradient of e to the x is simply e to the x. And this will become very important in the differentiation section of the course. There's also some key facts to remember about the graph of y equals e to the x. And we can see this graph here. This is y equals e to the x. Okay. Now the first thing we need to be aware of here is that this crosses the y-axis here at 0, 1. And we could verify this fact here by using y equals e to the x. Well, this must occur when x is 0. It crosses the y-axis when x is 0. So in that case, if we say x is 0, that's e to the 0. And we know from our work on indices, anything to the power of 0 is equal to 1. Okay? So it always crosses the y-axis at 0, 1 there. Okay? For y equals e to the x. We can also see here that as x tends to infinity, e to the x tends to infinity as well. So as x tends to infinity, we can see e to the x also tends to infinity. Okay. And what we can also see here is that as x tends to minus infinity, so as x tends to minus infinity, we can see that e to the x tends to 0. Okay, and we can see that from the graph here. So as we tend to minus infinity, our graph tends to 0 here. E to the x tends to 0. And finally, our final property here is that e to the x is never negative. Okay, so e to the x is never negative. Okay. We can also say that y equals e to the ax plus b plus c is a transformation. So let's just write this down here. Okay, and let's do this in a different pen colour just to highlight that this is talking about transformations now. So if we've got y equals e to the ax plus b plus c here, this is a transformation of y equals e to the x, where a is a horizontal stretch, b moves this horizontally, and c moves this vertically. Okay. And finally, y equals e to the minus x here reflects y equals e to the x in the y-axis. So y equals e to the minus x reflects y equals e to the x in the y-axis here. Okay. So just so we're aware of that fact there. Okay. So that gives everything we need there to start with the exponential function. Moving on now to take a look at the natural logarithm. Now the inverse function of e to the x is the natural logarithm. And mathematically, we write this as ln of x. So this is ln of x. And this is the logarithm with base e of x. So we'd write this here as log x. So this logarithm of x base e. Okay. However, this notation is pretty rare. We would normally just use ln of x. Okay. Now, all the laws of logarithms that we're already familiar with can be applied to the natural logarithm. So in that case, the natural logarithm of a plus the natural logarithm of b, well, we can express this as one single natural logarithm here, and that's ln of ab there. Okay. Again, another property here that we can use is the natural logarithm of a minus the natural logarithm of b. And again, writing this as a single natural logarithm, this is the natural logarithm of a over b there. Okay. And finally, using the power rule here of logarithms, for the natural logarithm, if we've got ln a to the b here, well, we can bring this b down in front so that we can write this simply as b ln of a there. Okay. Now what we can see here on the right, on this graph here, well, in blue we have the graph of the natural logarithm. So let's write this down in blue here. So this blue curve here, that's y equals ln of x. Okay. And this is a reflection in the line y equals x here. So this line directly in the middle here is y equals x. So let's note that here. So this is y equals x. And in red here, what we've got, if we try to stand in red as well, is y equals e to the x here. So in red, y equals e to the x there. Okay. And like we said, this is just an inverse here, simply reflecting this in y equals x. Now there's also some key facts that we need to remember about the graph of y equals the natural logarithm of x. So let's write these down here. Okay. So some of the key facts that we need to remember here, well, it crosses the x-axis at 1, 0. So this point here, this is 1, 0. So it crosses the x-axis at 1, 0. Another point that we want to remember here is as x tends to infinity here, so as x tends to infinity, the natural logarithm of x also tends to infinity. Okay? So the natural logarithm of x also tends to infinity. And as x tends to 0 here, so as x tends to 0, we can see that the natural logarithm of x, tends to minus infinity. Okay, so as x tends to 0, the natural logarithm of x tends to minus infinity. And we also know here that the natural logarithm of x does not take any values for x being less than or equal to 0. So we know that as well here. Natural logarithm of x does not take any values for x less than or equal to 0 there. Okay. And as ln of x is the inverse of e to the x, and this is a logarithmic function, we have these formulas that relate the two. So here, e to the ln of x simply equal to x there. Okay. And we also have the natural logarithm of e to the x, and this is simply equal to x. Okay. So this relationship here is very, very important and will help you massively when solving problems using natural logarithms and the exponential function. So that gives us everything we need there for the natural logarithm, and that concludes this Maths Made Easy video on the exponential function.